we are going to look a new video on ladder problem. We are going to look June 2019 paper 3, question 7 Roman 1. A uniform ladder of weight W and length 2a rests in limiting equilibrium with one end on a rough horizontal ground and the other end on the rough vertical wall. The coefficient of friction between the ladder and the ground and between the ladder and the wall are mu and lambda respectively. If the ladder makes an angle theta with the ground, where tan theta equals to 5 on 12. A. Show that 5 mu plus 6 lambda mu minus 6 equals to 0. B. Find the value of mu and lambda given that mu lambda or mu times lambda is equals to half. Okay, those are just key things you need to take note in solving the ladder problem. Firstly, in ladder problem you must draw your diagram, because if you draw a diagram it will ease your manipulation in solving questions. Okay, the second part is just that when the question says it is resting on a rough vertical or horizontal wall, it simply means that the force that is taking place there is a frictional force. Okay, the third point is that when the question says smooth vertical horizontal floor or ground, it just simply means that there's no friction at all taking place there, so it means that the friction there is 0. Okay, finally you need to resolve the forces and the moment of the ladder. Starting with the weight that's going downward. The question says it makes an angle theta. Question says that it just makes an angle theta with the horizontal. So okay, from resolving the moment, for example, for resolving the moment, you realize that the moment of a force simply defined by the moment of a force defined as the product of a force, or the product of the force and the perpendicular distance from the line of action of the force to the pivot. I repeat again myself. The moment of a force is defined as the product of a force and the perpendicular distance from the line of action of the force to the pivot. So what does that mean? It means that I have here a force, which is the weight. This force needs a horizontal perpendicular distance. So I have a force here, W, acting vertically. So I have a force here acting vertically. It means that the vertical force needs a horizontal perpendicular distance. And we know that from the weight going downward is A. So the distance from the weight to the ground is simply A. So I'll have now the distance will simply be equals to A times cos theta. Why am I adding cos theta? I repeat again myself. I have a weight acting vertically downward, which is a force, and it needs a horizontal perpendicular distance. Mean that what? If I need a horizontal perpendicular distance, it means that I'll use a cos trigonometric function and I'll multiply it with the distance from the weight to the ground to find the distance, or to obtain the distance. So when I have now the distance, I'll simply multiply with the force to have the moment about that point. in which in this case is a clockwise moment. Okay, about now anti-clockwise moment, you realize that at this point where we're having the frictional force of the wall, the force that is acting about this point is simply a vertical force going upward, and we and the force that is going upward the force that is going vertically upward means that it needs a horizontal perpendicular distance, in which the distance between them is just 2a. And then now the distance about that point is simply what? 2a cos theta. Why am I adding this cos theta? It's just that I have a vertical force that is acting about this point. Vertical force means that what? It needs a horizontal perpendicular distance. Since I need a horizontal perpendicular distance, it means that I will use a cos trigonometric function multiplied by the distance between that point to the ground, which is 2a. So the distance about that point will be 2a cos theta, which is the angle between the ladder and the ground, times the distance, times the 2a to obtain the distance. Then now obtain the moment, I will simply multiply the force times the distance so this force here is the weight. So at this point here is a clockwise moment, so from here is an anti-clockwise moment. So the sum of the clockwise moment is equals to the sum of the anti-clockwise moment. So to solve now the second anti-clockwise moment, you realize that this force here is a horizontal force, means that what? It needs a vertical perpendicular distance. Since the force is horizontal and needs a vertical perpendicular distance, it means that the trigonometric function that I will use here will be sine theta. So the distance here will be equal to what? The distance between that point to the ground, 2a, times sine theta. Since it needs rather a vertical perpendicular distance, I multiply by the trigonometric function sine. Okay. And then now to add the moment about this point, I simply multiply the force and the perpendicular distance. So now to obtain now the sum of the moment, I will now do the sum of the anti-clockwise moment is equal to the sum of the clockwise moment, as we are seeing from this above taking the moment. So I have the sum of the clockwise moment is equal to the sum of both anti-clockwise moment. So whereas that from substituting R, the normal reaction force of the wall is given as mu, the normal reaction force of the ground. I just substituted it, still the same thing here, substituting, and then now I'm now cancel the weight on both sides. I cancel the weight on both sides. This is the remaining part. Now I divide all through by a cos theta. If I divide here by a cos theta, the remaining part will be 1. I divide here with a cos theta. This is my remaining part. I divide now here with a cos theta. A cos theta, the a will cancel. Sin theta and cos theta will give me tan. Theta. Then now, but in the equation you are just beside that tan theta is equal to 5 on 12. So I just substitute the 5 on 12 here. 2 here will cancel 1 time, and 12 6 times. So at this point now, I'll now multiply both sides by mu lambda plus 1. So the mu lambda plus 1 cancel both here and here and multiply here by 1. So this is the remaining part here. Then now at this stage I now multiply all two by 6. Multiply now all two by 6, I have 6 mu lambda plus 6 equals to 12 mu lambda plus 5 mu. I'll now send the 6 mu lambda to the left hand side to have 6 mu lambda, and 6 to the right hand side to have minus 6 equals to 0, to have the proof which is as required. Okay, for the B part now, we are asking us to find the mu and lambda. So we have the first equation here, which is our equation 1, and the second equation is given in the equation. So now I just simply substitute the lambda mu in the first equation to have mu, and then now once I have mu, then I'll substitute the mu in the second equation to have lambda. So these are just all for the ladder problem. Thank you for watching the video. I hope it will help you a lot. Thank you.